So I've been playing around with this printed in place CVD idea, and I've gotten pretty comfortable with it now, and I'm able to print it in different materials and on different printers with a good rate of success. Some don't look as good, but they do work. I'm not sure about the strength. Let's figure it out. Huh. It's actually stronger than I thought. Well, that was still pretty dang strong for how small the piece inside there is. Let me zoom in there. So yeah, it's a pretty small piece, so I'm genuinely surprised it can take that kind of punishment. Okay, that side was a little weaker. Still, PLA, so it's not as strong. Yeah, and yeah, I've gotten pretty comfortable, so now I can just take it off the bed plate, do a little bit of this. Come on, there you go. And then I have a working, come on, not in front of the camera. Alright, there you go. And then I have a working CVD. You know, a little bit of oil will make it work better. And apparently some printers do it a little bit better than the other ones, but as you can see, it does turn. Yeah, this one came out a little bit, much better actually. And this one, oh god, this one is so pretty. And this came on my least favorite printer, which is my old MakerBot, which is crap. And somehow it made this little gorgeous thing. Okay, but the issue here is that if I wanted to use this in an assembly, it's, you know, I guess if you're doing, I guess there are some situations where you would just have a printed in place, a straight CVD of this sort. Like this could be the front axle of a four-wheel drive car, and this could be the wheel hinges, and you know, since they steer like that, you can print the whole thing straight up like that, no problem. But what if you wanted to do a more complex suspension? Well, then you would have to print something at an angle. So that's what I've been experimenting with. And yes, this is a little bit larger, but I wanted to show that this is how it prints off the plate. You can see it goes vertically and then to an angle. Ideally, I'd like to have it vertical, angle, vertical again, but one step at a time. So just wanted to show this does work. Let me see if I can do it without tools. Stupid brim. Okay, so obviously I have to separate the usual little things here and there, and I have to be delicate. Even though this is tougher than the little guys, it's been scaled up twice the size. I might have to use tools just so that I don't embarrass myself by breaking it as I'm recording it. So, what do we have to cut? I forgot. Okay, that it's actually should be free already. So what's the holdup? Definitely wants to turn. Aha! It's a bit of a... Okay, there you go. Did that work? Let me see, let me judge it. Okay, I didn't bring... Yeah, there you go. So it has to be worked in a little, because there are little micro supports inside. But as you can see, it does work. So I still have to design the double CVD hinge so that it's, like I said, it becomes parallel output. But it's pretty cool that this actually printed and worked with a piece that was of diagonal like that. I really had my doubts, but yeah. But what about in that size? Because this is obviously too big for something like my printed in place RC car. Where the hell are you? Like, yeah, obviously this is not gonna really work, is it? Huh? It's gonna be a little weird if I want to do some kind of suspension. Although I don't know, maybe I could do like some Mad Max car, and there's like Army of Darkness, and I put a giant ass blade up front and just
Say hello to the 21st century.
Alright, back to business. So, does it work at a smaller scale? And yes, it does. So, this might still be a little too big for anything here. I'm not sure. I haven't really thought that far ahead yet. But it does work. And actually, I posted a video last time where I'm holding this with my hands and there's bearings on it, and I let the motor turn, and you can hear a lot of noise. I mean, it works, but there's a lot of vibrations and power loss. Well, with this frame, it actually makes things a little rigid, so there's still power loss, but not as much. So as you can see, I put my PTG version here. Okay, so yeah, this motor turns at about 16,000 RPM, and it has, basically it's turning at 11,000 right now, so yeah, it is kind of a substantial power loss, but again, if I were to use this in a project somewhere, it wouldn't be directly connected to a motor. There'd be some gear reduction, so it would never even actually spin this fast, and there'd be more torque behind it, reducing power losses. It's still pretty cool that this actually works. So I'm actually kind of impressed. I really had my doubts that this would work because of the way it's printed, and now I have to figure out, oh wow, look at that, look how smooth that is. And yes, I did add a little bit of oil. It wasn't as smooth off the print, and it does help that it's PTG, which just feels a lot smoother. But this does open possibilities to weird printed in place mechanical ideas. That's it. Bye.